record this presentation to share the video, and I will also be sending the slides to all registered participants. So before we begin, let me introduce myself. My name is Gabriel Gasque, and I'm head of outreach at protocols.io. It is really a pleasure to be presenting this webinar to you. I am sharing my screen, and as I mentioned before, I will be recording this presentation and sharing the video and the slides with the participants. I have a background in experimental neuroscience with doctoral studies and postdoctoral training. And before joining protocols.io as head of outreach, I was an editor in the open access journal PLOS Biology for 9 years. I consider myself a scientist and also an advocate for open science, experimental reproducibility, and research integrity. What you see on the screen now, it's the agenda. I will speak for about half an hour, leaving 10 to 15 minutes at the end for questions, which you can start typing in the chat box or unmute yourself at the end of the presentation. So in this webinar, we will go over some of the more general points in terms of the motivations for creating protocols.io, what our mission is, and how our platform and tools can make your work easier and faster, both in the research lab and in the classroom, as well as to increase your reproducibility as an experimenter. Although I will be sharing a lot of information, we will not have the opportunity to go over all the details of the different functions and tools. For that reason, I will share now with you some resources, some training resources that you can browse for more information. So first of all, we have these live streaming webinars. We run different webinars covering diverse topics, some of them tailored for the new users, and some of them for more experienced users. So if you go to our website, protocols.io/webinars, which I will open on the internet, you will see that we have scheduled webinars targeting different time zones. Some are introductory webinars like this one today, so some are more advanced. We also have what we call drop-in clinics, which are like office hours. These are sessions that don't have an agenda, and you can come with specific questions about the platform and talk to one of our staff. We also have a series of pre-recorded tutorials that explain with short videos about tools and features of the platform. And if you scroll all the way down, you will see that there is a link to request a one-to-one demo, which are interactive sessions for you to ask any question related to the platform. And you can share your screen. Us will be sharing our screen and teach you in a very dynamic way how to do what you want to do. So let me go back to the presentation now. Okay. So now let me tell you about protocols.io itself, what it is, and why it is useful for researchers. So protocols.io is a virtual platform for the collaborative development, sharing, and publication of detailed, up-to-date, and reproducible experimental protocols before, during, and after publication of a research article. Protocols.io was created by researchers for researchers. We have collected a series of tweets that comment on the difficulties and frustrations of trying to replicate previously published experiments. And as you can read on this slide, Daniel goes from reference to reference, trying to understand how certain devices used in a 2017 paper were fabricated. And when he finally reaches the original publication from 2009, it simply says, devices were fabricated with conventional methods. And that's all the methodological information that he gets. This is just an example that highlights a widespread problem. That is very often, the information reported or included in the materials and methods sections of published articles is insufficient to allow the reader to understand what was done and to reproduce the experiments. As part of the background on why we created protocols.io, we like to talk about the Cancer Biology Reproducibility Project, which was a $1.5 million initiative coordinated by the Center for Open Science and by Science Exchange, with the goal of trying to independently replicate almost 200 experiments from about 50 high-profile papers on cancer biology. What the Reproducibility Project researchers discovered very soon after the project began is that it is very difficult to replicate previously published work. And there are several reasons why this is the case. But one of them is that the original researchers didn't document in their articles with enough detail what they did and how they did it. What you see on the screen is the Center for Open Science website that summarizes some of the results of the Cancer Biology Reproducibility Project. And as you can see, from the 193 experiments that they tried to replicate from 53 articles, 0% of those protocols were completely described, 0%. Which made it impossible to reproduce them without contacting the original authors. Furthermore, and equally striking, when the researchers from the Reproducibility Project contacted the original authors, they also discovered that these did not always could tell how exactly their own experiments had been done. Therefore, the problem of lack of reproducibility goes beyond the lack of adequate reporting in published articles, but also highlights deficiencies in the way researchers keep record of their own experimental protocols for housekeeping. This is caused, among other reasons, because people move from labs. For example, students graduate and leave, postdoctoral researchers become faculty elsewhere, and so on. And it's also not uncommon that a physical paper lab notebook gets lost, misplaced, or is damaged. Therefore, we thought that a system for the proper storage and exchange of detailed experimental protocols was needed. So protocols.io mission is simple. It's about making it easy for researchers to share the details of their experimental methods before, during, and after publication. Generally speaking, protocols.io comes in two flavors. So we have a free open access version or repository, which provides unlimited protocols as long as these are made public. So for free, you can publish all these protocols, getting a unique DOI or digital object identifier for each of them. With a DOI assigned, the published protocols become permanent and citable. In addition, we have premium accounts that offer everything the free plan offers, plus an unlimited number of private workspaces and private protocols, premium training, and for the institutional accounts, a free protocol import service. You can find more details about our plans at protocols.io/plans/academia. And I will explain later during this presentation what workspaces are and how the protocol import service works. Some of you might already have an institutional premium account if your university is a partner of protocols.io. You can check this by going to the website protocols.io/institutions and search in this menu that I'm showing you in the movie if your institution is a partner of protocols.io. And if that is the case, then you will have all the benefits of an institutional account. Now, going back to our mission and our features. In addition to improving the documentation and reproducibility of experimental methods, protocols.io offers many other advantages that are directly or indirectly linked to this general aim. And I will use the next few slides to discuss how protocols.io can help you improve your everyday work, whether it's research or teaching. So we launched protocols.io in 2014. We currently have over 100,000 registered users who have created over 12,000 public protocols and over 40,000 private protocols. The public protocols are all open access, which means that anyone can search for them, read them, use them, copy them, and create new versions for free. Last year, our protocols had over 1 million readers. Several organizations, including over 500 scientific journals, funding agencies, and educational and research institutions support and promote the use of protocols.io. As I will describe next, protocols.io can support, facilitate, and increase the quality of your research and teaching because it allows you to manage and share research data and protocols. It allows you to simplify teamwork and improve collaborations, and it allows you to save time and keep your work organized. Protocols.io is also a tool to increase your impact as a researcher. To get granular credit for your technical and methodological discoveries and innovations, and to improve your performance as an educator. I will try to create a bridge between the different features and tools of protocols.io and the benefits that it offers for research and teaching, explaining how the architecture and functionality of the platform enable everything I listed before. Organize your work, collaborate, save time, increase your impact, get credit, and teach better and easier. But before I go into the details of the features and their functionality, I would like to briefly summarize why using protocols.io gives you precision and flexibility in your experimental research. So to do that, I'm going to show you an example of a protocol created and published in the platform. So as you can see, our protocols go far beyond what a static PDF offers. They are usually written in a recipe-like step-by-step format. Different sections of the protocol can be coded in different colors to ease readability, and you can navigate to the different sections. The protocol can be supplemented or enriched with pictures, images, and even videos. And these protocols are interactive because readers can add comments and the authors will be notified and they can come to the platform and respond to those questions or comments. It is very easy to create a copy or a fork of the protocol. And they are also dynamic because the protocol can be run directly from the computer, tablet, or cell phone. If I run my protocol in the computer, I can tick off every step as I make progress. I can add comments to a specific step or even tweak it if that's necessary. The platform comes with an integrated timer that I can set to different times for different steps. And when the time it's done, the computer or cell phone will beep to notify me. At the end, I can save the record of the run as an independent file. So now, the platform itself has three main sections. It has the workspaces that I mentioned before, the file manager, and the editor. And I will explain how they relate to each other and what they do using a simple cartoon. So the workspace is where everything happens. It is from this space that you create protocols, organize your work, and collaborate with others. The workspace has a folder that is organized by the file manager. And in the file manager, you can use the editor to create protocols. During my explanation on what each of these sections or features does and how they relate to each other, I will be moving back and forth between them. So if you go to our website, what you see on the screen is the landing page. You can create an account if you have not already done so and log in. Once you log in, the system will ask you to create your first workspace, which you can make public, which means searchable, or private. At this stage, the system will also ask you if you wish to invite anybody to join your workspace as a member, but you don't have to do so. In this example, I am inviting myself. So once in the workspace, you can access its folder, which will take you to the file manager, which is empty now because the workspace is new. To create a new protocol, you select the new button, you select new protocol, and that will take you to the editor. And that's what you see on the screen. And you start by choosing one among different templates that you can further customize with the editor. The file manager will eventually contain, display, and organize the protocols you have created within the workspace. The file manager supports any file type, not only protocols. You can upload Word documents, PDF files, Excel spreadsheets. The file manager helps you archiving, auditing, and exporting because it can connect to Dropbox, OneDrive, and Google Drive. And it has been designed with enterprise-grade security and backup functionality. The editor, which I briefly showed you before, and which is the tool to create protocols, has detailed components, a granular editing history, and allows all changes to be reverted. It also allows concurrent editing, which means that two or more collaborators can work simultaneously on a protocol the same way that two or more people can work simultaneously in a Google document. The protocol itself is written in a recipe-like step-by-step format, and different sections of the protocol can be coded in different colors. You can also upload or embed figures and videos into your protocol, like the one I show you here on the screen, which is a protocol that teaches how to record a movie using a specific microscope. And the videos can be inserted into the protocol, or they can be a link to a YouTube video, as the example that I'm showing you right now. And I'm sure that many of you already have a long list of existing protocols in PDF or in Word format. And this is not a barrier to adopting the use of protocols.io. We offer our users a protocol import service by which you can send us your existing protocols in any format, and we will upload them in the step-by-step format of protocols.io into the platform. We will double check to make sure that there are no errors or typos relative to the document that you provided. And if you're happy, we will reassign the protocol to you. So privately, as a private document, and which you can publish whenever you feel ready. This service has a cost. But if you have an institutional account, the import service of your first protocol is free. Now, going back to the workspace. This is the space for collaborations. You can invite anyone to join your workspace. It can be a student or a postdoc, another faculty member within the same institution, or external collaborators. To invite collaborators, you go to the administration menu of the workspace and you select Manage Members. And then you can invite a new member by typing their email address. You can also manage the privileges that these members will have, and you can limit what they can do within the workspace, such as inviting other members or sharing or deleting files from the workspace folder. Workspace members can comment on the protocols you have created and shared with them, or ask questions. And this slide shows you how the functionality works. So the reader selects the plus bubble, can write a comment, and as soon as the comment is posted, the author will receive a notification. They can come back to the system, answer that comment or questions, and all this back and forth will be recorded in the platform. The members of the workspace can also make changes to the protocols. And as I mentioned before, there is a detailed log of all changes implemented to a protocol. And these changes can be reverted if needed. The members of a workspace can also create their own protocols in the folder, or they can copy an existing protocol and modify it according to their needs. For example, the original author could have created a protocol optimized to work in mice, and it can be modified and optimized to work in rats in a second version. The platform also allows you to compare two versions of the same protocol. In this case, the new version is to the left, and the changes automatically detected by the platform are highlighted in red. And even if a member of your workspace leaves, because, for example, a student graduates, the protocols will remain organized, up to date, and available in the file manager. As mentioned before, the file manager supports many types of documents, not only protocols. You can upload PDFs, documents, the Microsoft Word, or Excel spreadsheets, and everything can be further organized into subfolders. You can also select to export your protocols to Google Drive, Dropbox, or OneDrive, or transform them into a PDF and print them. So you can have a hard copy of your protocol at your bench next to you while running your experiments. And what you see now on the screen is a view of a PDF created from a protocol, starting with the materials and then going to the step-by-step protocol. But as I mentioned before, in addition to printing and having a hard copy, you could actually run the protocol from your computer or tablet. And ticking off every step of the experiment as you make progress. And the files generated when you hit the Save button can also be exported. You can also collaborate beyond your workspace by sharing your protocols with specific people via email, as I showed you to the right hand of this slide, or by publishing them, making them available to the whole world. Publishing the protocol will assign to it a DOI and will allow anyone with an internet connection to search for it and to access it. It will also create a lock that will not allow further changes to the protocol, making it a permanent object. A published protocol with an assigned DOI is a citable object that can be referenced to in a paper, giving credit to the authors, methodological developments and improvements. The reference will also be linked to the protocol in protocols.io. So the reader will have access to the interactive step-by-step protocol, even if the paper was published behind a paywall. And the platform keeps record of all traffic and use of the protocols, including number of views, number of bookmarks it has received, number of exports people have made, number of copies, comments, and citations. Any reader can comment or ask questions on a public protocol, as I showed you before, and the authors will be notified. And this will expand your network of collaborators and strengthen your impact and reproducibility. And we have seen cases where researchers report that sharing and publishing detailed protocols leads to an increase in the number of collaborations. Once the protocol is published, any reader can make a copy and modify that copy according to their needs. And the platform has a memory that will link any copied protocol to the original one. In this way, the original authors also will maintain and earn credit. For example, this one is a protocol that is a modified version of an original protocol created by somebody else. The platform tells us that this protocol was forked from another protocol, which is what I am highlighting in blue. And the reader can access the original protocol by following the link. Therefore, all authors get credit for the protocol creation and optimization, and the reader has access to the history of changes and to the evolution of the protocol. And with an assigned DOI, you can use the link to protocols.io to simplify the materials and methods section of your papers. For example, in this example that I show you on the screen, what you see is a paper that was published in the journal PLOS Biology. The authors had previously uploaded their detailed protocols into protocols.io, receiving a DOI, which they included in the paper in the materials and methods section. By following this link, the readers have access to the detailed step-by-step protocol in protocols.io. And a really nice thing about how protocols.io works is that the protocols are versionable. So if the authors updated their protocols since time of publication, the reader will be notified automatically that newer versions of this protocol exist. And they will have access to the original protocol that was published together with the paper that is now highlighted in gray, as well as to the newer versions that the authors created since the time of publication. Protocols.io recently established a partnership with the journal PLOS One, whereby you can submit from the platform a novel protocol for peer review and eventual publication in this journal as a lab protocol article. The published lab protocol in PLOS One will be bidirectionally linked to the interactive and dynamic protocol in protocols.io, and the protocol in protocols.io will contain a flag that indicates that this protocol has been peer reviewed. And as I mentioned before, once a protocol is published and receives a DOI, it can no longer be modified. However, it can be forked and modified as needed and newer versions created. Now, going back to the workspace, you can create multiple workspaces in your account depending on your research and teaching needs. You can create workspaces for different research projects or to teach different courses. Each workspace can have different members and contain different protocols and documents, giving you great flexibility for organization. And finally, protocols.io can also be used for teaching, not only to share experimental protocols with the research community. So what I show you on the screen is an example of how protocols has been used to teach a class. And as you can see, the teacher gives detailed instructions to the students on how to perform a sequence alignment. The teacher enriches the instructions with videos and images, and the students can ask questions about specific steps, and all discussions will be recorded. The teacher can also indicate which steps of this workflow are optional and which steps are critical. In sum, protocols.io helps you stay organized, collaborate efficiently, save time, increase your impact, get credit, and teach efficiently. And with that, I will be happy to take some questions. And again, I do apologize for the initial problems with the link, with the Zoom link. Are there any questions? You can raise your hand. I don't see anything typed in the chat.
Thanks for your presentation.
Absolutely.
Yeah, it's really nice strategy to make the protocol for everybody. But I have a question is if one protocol published and if all the people cannot reproduce and what can you do? How can you manage the? How can you evaluate which protocol is uh, is right or which protocol need to be modified?
Okay, so the question is, and correct me if I'm wrong, if a
Yes.
protocol is published and people cannot reproduce it, what quality control do we have
Yes.
over those published protocols? So we are not a journal. We don't do peer-reviewed. So we work more like a repository, like a preprint repository, similarly to bioRxiv. And so what you can do as a reader, if you cannot reproduce an experiment, you can always ask via the comment feature to the authors about specific steps of the protocol. That's one thing. And the second thing is that, let me open a specific protocol so you can have a look at it. So let me go. So what we see is that there is a works for me button, and sometimes people click on that button, and so different protocols can collect different numbers of work for me clicks, and then when you're searching for a technique, you can sort the protocols based on how many times people have said that that protocol worked for them.
Oh, I see. Yeah.
But again, we are not we don't peer review these protocols.
I see. Yeah. So it means that you also don't retract any protocol, right?
So we do an initial screen before publication. If you send a protocol to be published, we make sure that what you are publishing is a protocol, and we filter out spam. But we don't verify the quality of the protocol itself. And we retract protocols if the authors contact us and they wish to retract the protocol. So that can happen, but it has to come from the authors. Yeah. Unless we made a mistake and we let spam go through, which could happen, but we do just a very initial light assessment that everything that is published is actually a protocol.
I see. So may I have one more suggestion? May I have one suggestion here is because you have the button work for me, so every protocol if it's work, so the researcher can click on it, so all the people will know that this protocol should work. And should you also create the other button say that it doesn't work? So some people, if it cannot reproduce it, they also can click on it. So somehow the new researcher, when they look for the protocol, they have some of the overview that this protocol, how can have the general view, kind of the estimate the possibility of the reproduce of this protocol.
Yeah. So I wrote down your suggestion, but also something that you can do is actually you can read, you can see if the protocol has comments, and you can also see how much the readers might be struggling using that specific protocol. But it's not as explicit as the button that you suggested.
Nice. Yeah. Thank you very much.
Absolutely. There are 3 questions typed in the chat. Okay, there is a question that says, can you review how to upload existing protocols with and without institutional access? So, absolutely. Everybody can send us an existing protocol in any format, and we will upload it for you. If you have institutional access, you can send us one that we will do for free. If you don't have an institutional access, then we will charge for all protocols. And I think that the cost starts at $50 and goes up depending on the complexity and the length of the protocol. However, it is also easy to do it yourself. And there are at least 3 ways of doing it. The first one is that you can just drag and dump the protocol in its original format into the file manager, because the file manager accepts any type of document. A second option will be to add the protocol as an attachment to your protocol. So you can create a protocol. I'm gonna just choose to save it here. Let me open here, sorry. So you create a protocol. If you go to the tab that is called description, at the bottom, it accepts an attachment, and you can then upload or drop here your protocol as an attachment into a protocol created in the platform. And the advantage of doing it like this is that you can give the protocol an abstract, sorry, a title and an abstract, which will make it more searchable. And the third option of importing an existing protocol is to create the protocol. And then in the steps section, there is a button. I don't know if it's too small for you to read, but it says, if you have an existing protocol, you can insert steps from a text file. So you can copy the steps in your text file, click this button and paste the text here, and the platform will transform the text file into the steps in the protocol itself. So those are the 3 ways: dragging and dropping, creating an attachment, or importing the steps using the insert steps from a text file function. And you can always send us your protocol and we will do it for you with a cost if you don't have an institutional account. Did I answer your question, Jennifer? Okay. Anything else?
I have one more question.
Absolutely, go ahead.
Yeah. So my question is, if 2 or 3 people, they publish the same protocol, so what will you do?
Well, people, we have many protocols on how to run a PCR.
Yeah.
Many protocols on how to prepare PBS. And that's fine. The readers will use whatever protocol works for them, or they will create their own protocol. So protocols itself, like recipes, are not subject to copyright. So you can just publish a protocol that has been previously published. It will be scholarly, though, to acknowledge that, and there is a section for reference. It will be scholarly to acknowledge that your protocol is based on somebody else's. But there are many protocols describing how to run a traditional PCR, and that's fine.
Yeah, I see. So it means that there are no copyright in the protocol publication, right?
No. Recipes are not copyrightable.
I see. Yeah. Yeah, thank you.
I'm gonna stop the recording now in case somebody else wants to answer a sorry, wants to ask a question without being recorded,